just another day on the unit circle. We've kind of shown you what the unit circle does, and today we're just going to review it and show you just a little bit more. So when we look at the unit circle, it's really just the reference triangles that are being drawn. So just like we did where we drew our triangles down to the closest x-axis, we just form a whole bunch of right triangles that have a hypotenuse of 1. So the cosine is still the adjacent over the hypotenuse, but the hypotenuse is 1, so it's really just the adjacent, which would be the x value on your triangle. And so I'm just going to put that it would be the adjacent over 1. And the adjacent side would be this x value right here, right? Because that would measure the length of x and that would measure the length of y, which is where that x value comes from. The sine from this angle would be the opposite over the hypotenuse. Are you guys seeing how the opposite would just be y over 1, which is really just y. So that's where those x and those y values come from. And if I wanted to look at the tangent of the angle, the tangent would be the adjacent over the hypotenuse. The adjacent side from this angle, why did I say adjacent over hypotenuse? You guys, it's the opposite over the adjacent. I'm like, that is not working out right. I totally wrote down the wrong one. It said the opposite over the adjacent. The opposite side is y, and the adjacent side is x. Okay, so tangent is the y over x. That's where that comes from. All right, so again on this, it's just a reminder that no matter where you draw your angle, your cosine is your x value, and your sine is your y value. Just a reminder again here, that in this quadrant, both of them would be positive, right? We've already talked about that. And this quadrant, you'll have a negative cosine and a positive sine, right? Because my x value is negative and my y value is positive. Down here, I would have a negative sine and a negative cosine. They both are going to be negative this time. And over here, my x value is positive and my y value is negative, which means my cosine is positive and my sine is negative. Now we've gone over all of this before, right? So down here in this quadrant where it says that the angle or the measures here would be the cosine, and the sine right here where you're going from this angle, again, because my cosine is negative, my x value is negative, it would be a negative cosine, and my sine would also be negative in that quadrant because we're negative in both directions. And my x value is negative and my y value is negative. You guys following me on where we got those signs from last week when we did that? It's just from your x and your y values. So what's the exact value of each function? We go to our unit circle and we look. So I'm going to use this unit circle. I told you guys this one up here that has, I like this one better because the fractions are stacked on top of each other. If you want to grab one of those over here, you're welcome to trade to this one. It's different than the one that I gave you guys. But we're going to find the sine of 120, which really means we're looking for the y value at 120. So you go to 120 degrees on your unit circle, which is right here. The sine value is your y value, and in your ordered pair you have x here and y here. So what's your answer? The square root of 3 over 2. Questions on how I grabbed that off the unit circle? All right, cosine this time. Cosine's which value?
4 pi over 3.
Yeah, okay, the cosine, x or y?
X.
X. So you find 4 pi over 3 on your unit circle.
Negative 1/2.
Yep, and you find your x value, which is a negative 1/2. Okay, so we're really just reading that unit circle for our x and our y values. All right, so here's an example that looks a little bit different. It says the terminal side of an angle in standard position intersects the unit circle at point P. State the value of the requested trig functions. So again, we were told that we're in the unit circle. This is my x value and this is my y value where my angle intersects. So what's my sine value?
The y over.
The y one, which is what? Yeah, you guys, don't let it trick you. Sine is always your y value. It looks confusing here, but it's not. The sine comes from the y value in the ordered pair that your angle intersects. It says that this is the ordered pair that your angle intersects, so that's going to be your x and your y value for your sine and your cosine. All right, so what's my cosine value then? It's my x value, and my x value is negative 20 over 29. Okay, questions on that? So again, here's my ordered pair that my angle goes through in the unit circle. What's my sine value? The y value, right? The negative 0.9454. And the cosine? 0.3. Okay, so it doesn't matter if you draw the triangle or not. The x value is still the cosine and the y value is still the sine. So what about the tangent? We already decided that, and I showed you that like 3 times now. The tangent is the opposite. Well, the opposite is how tall it is, which is its y value, over the adjacent, which is how far it is away from 0 left or right, and left or right is your x value. So it's going to be your y over x. So we've already showed you this. We're just reviewing again today. So if we're going to find the tangent, it's really the sine over the cosine. Okay, here's a little joke for you. If you prefer the sine gerene over the cosine gerene. Yeah, it's not funny. Because what does it make? The
tangerine.
The tangerine, right? The sine over the cosine is the...
It's like a little orange.
Yeah, a tangerine's an orange. A baby orange. Okay, not so funny, but here we go. We're going to find the tangent of 11 pi over 6. So go to your unit circle and find 11 pi over 6. It's right here. Quadrant 4. So the tangent is your y over your x value. So your y value is...
0.1 or something,
negative 1/2, and your tangent value is, or I'm sorry, your cosine value is the square root of 3 over 2. You can seriously just punch that in your calculator. That way, use 2 fractions and a fraction, like to set it up that way, and then just plug it in. If you don't like using your calculator, you simply flip that second fraction upside down and multiply by it instead. And then you're going to have to rationalize the denominator, which would be the negative square root of 3 over 3 for your solution. So your calculator will do that for you. Or if you remember, you flip the second fraction upside down and multiply by it instead of divide. Okay? All right. So next example says find the tangent. Again, this is the point of intersection of the unit circle and the terminal side of our angle, meaning our angle stops at this ordered pair. Okay, so this again is my x value and my y value. If I'm finding the tangent, I'm finding y divided by x, right? So my y value is 40 over 41. My x value is negative 9 over 41. You guys punch that in your calculator and do it. I'm going to do it by hand real fast. I'd have 40 over 41 times 41 over negative 9. The 41s cancel, and I'm 40 over negative 9. Yeah, I like to leave it as an improper fraction. If it won't reduce, I'm going to just leave it that way. You could change it to a decimal point number if you wanted to, but I would totally just kind of leave it that way. Okay. All right. Now, I just want to remind you of a couple of things on this clock right here that has kind of maybe would have helped you on a couple of our problems that we've already had. So this clock is a circle, right? We have the center point here, and say I want to know how big the angle is between 1 and 2. How many degrees would be between 1 and 2? Yeah, well, how many degrees are in the whole circle? And how many equal parts did I break it into?
12.
Yeah, I broke it into 12 equal parts, right? So 1, 2, 3. So 360 divided by 12 tells you how many degrees each one's going to be. So yeah, 30. So each piece of the clock is 30 degrees between the two angles. So the other day on the problem, it asked you, first of all, how far did the hour hand move in degrees between, say, 1 and 2? Well, how far does the hour hand move? It would only move 30. But if we went between 1 and 2 o'clock, how many degrees would the minute hand move?
5 times around.
Well, yeah, well, so if we went between, if it was between 1 o'clock and 2 o'clock, the hour hand
Oh, the minute.
moves
Okay.
30 degrees. The minute hand moves how much?
360.
360 degrees. So that kind of just helps clarify what those problems have been asking you.
390,
Well, it makes one, okay,
because you add the 30. Because it went from the 1 o'clock all the way around back to the 2.
okay.
Wouldn't it be 390 then?
So Jesse's saying this, so if we went all the way from the 1, all the way around to the 2, Jesse's saying, did it make a full rotation, or did it make a full rotation plus 30 more degrees?
I made full rotation plus 30 more degrees.
Okay,
Not really, I made one full rotation.
somebody explain what you're thinking.